Hey, so it's kind of a strange and disorienting experience to be here so far, but I'm enjoying it, so we'll see if I continue to enjoy it. You know, when I go somewhere to speak, I like to say things that people don't necessarily expect to have heard, right? And often that generates differences of opinion, you know, controversy. There may be a little bit of that here, and I know that this talk is being videoed, and it may end up on YouTube. So I'll just preface this with a statement that, you know, I'm not really interested in having, the topics I'm going to talk about are the kind that in certain types of people induce nerd rage, right? They get all like, and they want to have arguments. And I'm not really here from the perspective of wanting to have arguments about these things, especially not internet arguments, because those are especially useless. So I'm just going to put this forth, right? This talk is about me having been a professional video game programmer for 16 years, an independent game programmer, and I'll talk about what that means. I've developed an aesthetic of what it means to program well that's very, very different from the one that I had during school and immediately afterward, right, coming out of college. And so I felt like coming back here that was a really interesting thing to talk about, to sort of think back to what I believed then and what I believe now and how it's different and why it's different. So I am perhaps best known for this game, Braid, that came out a couple of years ago. I started making this game in 2005, and it came out in 2008. So that's a 3.5-year project, which is kind of almost the length of a college education if you're an undergraduate, right? So that's a long time. Lines of source code is a pretty useless metric, right? But I wanted to provide some in order to give you something tangible to talk about the project. And you know, the reason it's useless is because it depends on what language it's written in, or some people like want to be all like testosterone driven and like, yeah, I use these automatic tools to crank out millions of lines of source code, but you know, whatever. So Braid was completely handwritten. You know, there's no generator tools used to build it. The code is relatively well thought out, although what that means, what well thought out means, may not be what you expect, and that's kind of what I'm going to be talking about here. There's about 90,000 lines of code. Some of that was pre-existing, so perhaps I wrote about 75,000 lines of code to make this game. Actually, I wrote probably a fair bit more than 75,000 lines, but then a lot of it was deleted, right, to end up with the final thing. Because when you're working on a project like this, you make stuff, delete it, make it, revise it, delete it, rewrite this thing 3 times, right? Now, this is a lot bigger than anything I ever did in school, right? The biggest thing I remember doing during college, you know, was like a programming language interpreter. It was maybe 16,000 lines by this metric. So this is way bigger than that, right? Here's the game I'm working on now. It's even bigger. Fortunately, I don't have to do this one all by myself. People are helping me. Now, both of these, from the context of video games in general, or software in general, you know, 90,000 lines, 120,000 lines, those are not huge programs, right? Even within video games, if you look at a game like a Call of Duty game or something like that, it's going to be a lot bigger. I don't even know how much bigger, but it's in the millions of lines range, right? However, you know, they don't write all those millions of times every time. A lot of it is reused. Even though these are not gigantic programs, for one person to do in a couple of years, it really is quite a lot of work. Here's another sort of straw man figure that gets thrown around. You know, the industry average lines of code per year for a professional working programmer is in the low 3,000 range. One of the reasons this is a straw man is it includes government projects where people are very bureaucratic and not very productive, but we'll just use it anyway, right? So if you try to approach independent game development like this as the industry average programmer and you have to write 90,000 lines, it'll take you 28 years to do that project. In other words, I wouldn't have been able to do it even if I started immediately upon leaving school. So that's obviously no good, right? So you might ask the question, well, okay, maybe if I'm a good programmer, I can be twice as productive as average or whatever, but to make this achievable, you have to be like 10 times that industry average figure, and how do you do that, right? And one thing you might think is, well, obviously you do it by writing lower quality code. If you just like pump out the code and you don't care how good it is, you can create a lot more because quality code takes a lot of time and effort. But there's a limit to how bad the code can be, and it can't really be very bad. So the platform that Braid launched on, the Xbox 360. Most of you guys have seen this. It's got 512 megabytes of RAM, and you can't use it all because there's an operating system that uses some of that. There's no virtual memory, so you can't have big files that magically page in or anything like that. It's got 3 cores, so you probably have to do some parallelism, especially because they are slow. They're in order, which means they will, if you try to read from main memory, they'll block for like 400 cycles every time you access a variable or something, right? So it's kind of crazy trying to be fast on this machine. And because of the package format and because the platform holder wants things to be encrypted and secure, reading files is very slow. And despite all these things, you have to pass a somewhat rigorous certification process, right? There's a very, very long list of requirements, and I won't go into them, but just to give you a taste, right? To have your game published, it can't crash even with an antagonistic user. So if somebody sits in front of your game and tries as hard as they can, like yanking out memory cards with their save game on it, like while you're saving, and hammering and throwing the controller across the room, your game can't crash, right? If you crash, you fail certification, back to the drawing board, right? There's performance limits, so your loading time is capped, right? As soon as the player says, start this game, there's some limit on how many seconds can pass before they're in the game and able to do things. And if you take longer than that, then you'll fail certification, right? Another thing they do is called a soak test, where they run your game for 3 days straight and make sure that it doesn't crash, right? So if you're running for 60 frames per second, like Braid does, for 3 days, you're displaying like 16 million frames of data, which each frame is a very complicated process of doing a lot of things. Remember, we had 512 megs of RAM, so if you leak like 4 bytes of memory per frame, that's 60 megabytes over 3 days, which is certainly more free memory than you had, and so you'll fail certification, right? So it has to be pretty high quality code. There are bugs in video games, some sneak through testing and et cetera, and you can actually get away with memory leaks if they're on infrequent user interactions, but for the most part, there's really a lot of testing that happens, and you really have to make sure things are solid. And that would all be pretty hard, doing that much code in that many years, if that was all you had to do. But as an independent game developer, you probably have to do a lot of these things too. Game design, level design, art direction, audio direction, business development, marketing, PR, and financial management. I had to do almost all of these things, probably all of them to some degree or another. So it wasn't even like I was programming full-time, right? So how do you do that? It's hard. Most people who try to do a game by themselves for a platform like the Xbox 360 do not succeed. They end up giving up. In order to succeed, you have to be extremely effective at getting things done. And it took me a long time to be that effective. Prior to developing Braid, I went through project after project where I was like, yeah, I'm an independent game developer. I've got this game. It's kind of cool. And I would like never finish it, and I would get discouraged, right? And it would take like a year or two at a pop. So this aesthetic that I'm about to talk about is sort of what I developed, starting at the end of college and getting to now, that has enabled me to be able to build relatively large projects for one person at relatively high levels of quality, hopefully repeatedly. Our current game, we could almost ship it. We're going to work on it another year or two. No, not two. One, to make sure it's good. And then, by the way, when I was in college, I had this stereotype of the guy I didn't ever want to be, which is like the grumpy old Fortran or COBOL programmer who like learned to program one day and then never learned anything new and like is kind of hunched in a basement and while kind of the world passes by and he says phooey on all this new stuff, right? That is not me, right? I'm often searching how to make my work process better and learning new things. However, I am going to say phooey on a lot of things that are being taught. So it's very easy to ascribe that to like, oh, he's a grumpy old programmer, but I swear to you that is not me. Okay, so the first thing I'm going to say is a lot of people who come out of school, while they were in school, they were learning how to be good programmers, and especially the people who are really smart, they pride themselves in being good. And what does being good mean? Well, I know a lot of intricate things, and I can like optimize code and make really good code. And the first thing I want to say is people come into industry with this idea that they want to optimize things, and those impulses are usually premature. Because compared to the most straightforward implementation of something that you can imagine, optimized code is a lot more difficult in a lot of ways, right? It's harder to write. It's harder for somebody to come along later and understand, or for you to understand, right? It has more bugs. It has a shorter lifetime, because optimization is often about, starting with a general case where we're not allowed to make any assumptions. Maybe you can only make the code so fast, but then you think, aha, if we ensure that the input is formatted in a certain way, or if things happen in batches or something, then we can get it a lot faster, right? Those kinds of constraints and assumptions change over time, right? They expire. And your optimization actually may become pessimization 5 years later on more modern CPUs, right? And it also makes that code harder to use by the rest of your code, right? Because that code has to talk to it in a certain heavily constrained way, right? When you call this function, your input has to be formed a certain way, and it can't have like any numbers greater than 1,000 in it or whatever, right? Insert random constraint there. Now, the reason this is bad is that most code that anyone ever writes is not performance sensitive, right? So in Braid, it's about 90,000 lines. I don't actually know how many lines of that are performance sensitive, but let's be generous and say it's 6,000, right? So 6,000 lines of that 90,000 line program actually matter in terms of the user experience, how fast it runs when you sit down to play. So if you enter into it with this mindset of, I'm going to write the best code possible, and best means fastest and other things that I'm about to talk about, you wasted most of your time, because you made most of the code worse, and you spent a lot more time thinking about it than you should, right? Remember, you have to be brutally effective to write this 90,000 line program. So if you think about that 84,000 lines that are not performance sensitive any more at all than you should have, then you're wasting proportional amounts of time, right? That 84,000 lines is almost your whole code, right? So if you take 10% longer doing that, then you've probably bloated your schedule by almost 10%. And when you're optimizing, 10% is nothing. You can easily double or times 5 the amount of time it takes to write that code. So the consequence of all this, which I've sort of been leading up to, is that optimization is usually bad. You don't usually want to do it. If you have the urge to optimize something, it's probably wrong. And this is a problem, because psychologically, this is part of the joy that we have, right? Part of what's cool about computers is doing things in the cool way. And I'm sort of saying you don't want to do that. It's not always bad, and I'll talk about that later, but it's usually bad. So now let's talk about data structures. We all love data structures, right? Data structures are about optimization, fundamentally, right? What happens is your program has a query that it wants to make, like what are all the objects in this area of the map, or like what are all the strings starting with Q or whatever, right? And data structures are about storing your data in a ways to answer that query efficiently, right? Unless you start talking about trivial data structures like a record or something, which is really just about, if I want the name, like where is that stored in memory? But that's kind of trivial, So when I say data structures, I'm talking about we're organizing things with pointers in certain ways to let us navigate stuff or whatever, right? So like a binary tree or a hash table, or pick your favorite skip list, anything, right? So data structures are about optimization, and I've just said that optimization is usually bad. Therefore, using the right data structure for the situation that you are programming is usually bad, because it constitutes premature optimization, right? I actually never realized this in terms this clear until I sat down to give this talk, but I absolutely believe this. Let me give you an anecdote about this that actually dates back to about the time I was in college. This game is Doom. It doesn't look like much now, but this was awesome back when it came out, because nobody really knew that computers could do like 3D this fast in like arbitrary spaces. And so shortly after this game came out, there was a mailing list. They released the source code, which was pretty progressive. And there was a mailing list for like people who wanted to make modding tools for the game, And I was kind of interested in that, so I was on that list. And there was a question that came up about the asset loading code in Doom, right? So the way Doom works is the assets in the game, right, which is bitmaps and sound effects and all strings and all that kind of stuff, is stored all in one contiguous package. And, at the beginning of that package, there's just a header that tells you the name of an asset and then where in the file it's located, and it's packed very tightly in that very simple way. Name, number of bytes in the file, name, number of bytes in a file, just like that. And a question came up on this mailing list, isn't that slow? And I went and took a look at the code, and I got nerd rage, like full on, man. I was like, this is stupid, They're taking an asset name, they're calling a function to look it up in the data, and they're doing a linear search, starting at the beginning and going through every name till they get to the end, right? I totally learned in school how slow that is, right? You should build a hash table so you can look it up in constant time, or you should at least, if that's a little too slow or whatever, just build a little more stuff into the file so you can binary search it, right? And then at least get log n time, right? And I said on the mailing list, yeah, this is totally lazy programming. They should do that and that, right? And John Romero's on the mailing list, and he emails back oh, you don't know what you're talking about, blah, blah, blah. We work really hard on this game and stuff. And I was totally convinced I was right. I had my nerd indignation. But no, I see very clearly at this time that I am totally wrong, right? Their implementation was the totally dumbest thing. Start at the beginning of the file, don't even unpack anything, scan the file till you find the thing. And that's absolutely right. And the reason why is because if I'd sat down to program that, well, first of all, if you profile the loading time of Doom, which I know about because I later ended up porting it to a couple things, it turns out that the amount of time that's actually spent in this string lookup is negligible compared to the other time spent loading the data, right? So that's the first thing. Even though the spider sense starts tingling when you look at this code, oh, it's important to optimize this. In reality, right, and reality is the important benchmark to think about, in reality it did not matter what the implementation is, except it did not matter in terms of runtime, but it mattered in terms of all sorts of other things, right? So, and what I would have done would have been much worse, like putting a hash table in there, would have been much worse along all other axes, right? It would have taken more time to implement, it would have used more memory, it would have fragmented the heap, it would have had less predictable performance characteristics depending on what the level is, it would have made the executable bigger, it would have been harder to understand and been more bug prone, it would have made the source code longer, take longer to compile, longer to link. All for no perceivable benefit, right? It's actually worse in every single way that I can think of now than what they did. But I was convinced at the time that I was right, Now take that is just one tiny piece of Doom. This is a very complicated game, right? So take the difference between what I would have done and what they did and multiply it not just by that tiny piece, but by the hundreds or thousands of pieces comprising this whole game. And you can imagine how much better of a job they did making this game than I would have if I had sat down to do it, right? They were simply better programmers than I was at that time, right? But I thought I was really smart. And there's an issue here that goes beyond being smart, right? There's some kind of issue of operational wisdom. I'll go into part of it later, but at least the most obvious part of it here that I should have had, but that people don't generally have is here's some guys who made this really cool game that I don't know how to make, right? And it's made by a couple programmers. If I think something's wrong with what they did, but what they did is kind of beyond my capability, maybe I just don't understand why they did what they did, right? Why am I saying they suck when all concrete evidence in the universe says that they don't suck, right? This is a pattern I see. Again, talking about the internet, this happens on the internet all the time, right? So just keep that in mind. So what I do now when I write a program is I use an array of records for almost everything. I don't know if you guys call it records still. When I say records, I think of Pascal, which is a language I never, so a record is just hey, here's the fields, and they're just you don't really care how they're stored, but they're probably stored linearly in memory. And then I just have an array of those, and I just put a record in the array, done. Almost every data structure in the games that I make now is like that. And the reason is because it doesn't matter, and if you think about it at all, right, then you're wasting time. So if I'm doing something with an array of records, I can type it in without thinking. I know it's going to work unless I'm way too tired, right, and make a terrible bug. I know it's going to be perfectly fast enough, and I also know that it's modular enough because it's not some crazy implementation, right? I know it's modular enough that if I need to rewrite it later for performance reasons, I can, because it's just 4 lines of code, right? But I won't do that rewrite until the need actually arises. But like I was saying, optimization is not always bad, right? Sometimes it's good. It's good when you focus on things that actually matter in terms of the physics of the universe somehow, right? And you actually get better results there, right? It's only bad when you spend a lot of effort optimizing for things that don't matter. So I'm sure that you guys are all familiar with these basic things that you might optimize, right? So you might optimize for speed, meaning you're trying to minimize the number of seconds your program takes to execute. You might optimize for space, which means you're trying to minimize the amount of storage it takes, right? But another angle on what I'm talking about here is that there's a third thing that you might want to optimize for, which is much more important than either of these, which is years of your life required per program implementation, right? So these are about how long it takes to run. These are about how long it gets you to even be able to run it. And this is more important than those other things, right? Or at least certainly equally important. And if you don't understand that this exists, and you only try to optimize for speed and space, not understanding this like limited life resource parameter that you also need to optimize for, then you're gonna push things into here and bloat this, right? And it looks like the other ones are very small and tight, right? So this is a valid optimization parameter or metric that you can use for optimization, and perhaps it is the most important one. Given again that I said that most of these people who go into independent game development fail because they don't get things done. Okay. So to bring this all back around to data structures are usually designed with memory or speed optimization in mind. They're not designed with life optimization in mind. Thus, you should use them sparingly, if at all. So generalizing even further from this, complicated algorithms are also not good, in part because they usually use complicated data structures, and we've already talked about how bad that is. So if you get the impulse to use a complicated algorithm, or you see one in code somewhere, it's probably a bad idea, right? For a lot of the same things that I was talking about with regard to optimized code, right? They require a large lifetime expenditure for a marginal benefit that possibly doesn't matter. They have a much shorter lifespan than simpler algorithms, right? More complication equals more assumptions about the input state and the output state. So if you propose a complicated algorithm, if you ask people to use one, or you spend a lot of effort developing one, the payoff had better be really huge, right? It better not be like 10% speed up. Nobody cares about that, right? For those of you thinking about going into grad school. You'll like this slide, especially from my point of view and the point of view of people in my field. Almost all applied CS research papers are bad. Theory papers are different. They're a different animal. But applied papers, which is like we're going to go in and we're going to try to speed up something in the real world or like do a better job at something. Almost all of them propose adding a whole lot of complexity for a very marginal benefit. They actually don't work in all cases because the inputs are limited and they're a lot less robust, and usually the paper doesn't disclose that. And they're usually supported by bogus numbers and unfair comparisons. An unfair comparison is something like, if you say, I'm making algorithm X, and it's a lot faster than algorithm Y, which is the traditional thing, then they'll put benchmarks showing you how much faster algorithm X is. But for the benchmarks, they used like off-the-shelf implementation of Y, whereas for their own implementation, they spent their whole, couple of years in grad school like performance tuning it, right? It's not a fair comparison unless you also performance tune the thing you're comparing against, right? And nobody ever does that because they don't have enough time. So like, I don't know. This really bothers me. The longer that I've spent away from school, the more I see that most of these papers are not useful. And if I were, and I easily could have chosen an academic career, right? So it's kind of easy, not totally easy, but it's kind of easy for me to put myself back in that place. And if I was in applied CS, I would kind of have a crisis of identity right about now if I was paying attention, right? I would be like, what is all this work for if so much of it is really just about giving somebody something to publish instead of being something that actually works? Okay. Taking a moment to pause, clear the air, go on to smaller topics. Here's one. I thought in school that if you were going to solve some problem in your code and you were going to write a specific system to solve that, that it's pretty much better to write a generalized system that'll handle a much wider set of inputs, because you might totally use that functionality, right? Actually, it's worse because you probably didn't need that functionality, at least probably not yet. So you just spent time implementing something you don't need. The generalized thing is probably more code and is probably harder to port because it's a larger volume of code. Again, the program takes longer to compile and link, which is something you pay for every day. But this is a little more subtle. generalized systems are less self-documenting than specific systems, right? So if there's some function that does one specific thing and you go into some code and you see it there, you, as a programmer who might be learning this code for the first time, or even for me, if I wrote something a year ago, I don't really remember it that well, I can come back to that and get context, right? I see exactly what this thing is doing and what its role is in the larger structure. And being a good programmer, in my experience, involves keeping as much of that larger structure in your head at once and seeing the interrelations between everything, right? So you can see this thing very clearly, but if it becomes a generalized system, you don't really know anymore what role it plays, right? It's less specific, and it becomes harder to delete from the code, right? Something that's very specific, if something is, I don't know, if something is about, strings that are, this is going to be a totally stupid example because I'm pulling it out from nowhere, but if something is about, strings that are ASCII and later, and it only works in that, does specific things in that realm, and then later your whole code is UTF-8, right? Obviously the thing that strings that are ASCII is no longer going to be needed, and maybe it's still connected to the rest of the code by a couple links, but you know that it'll be cleaner to like cut it, clean it up, and delete that thing, right? Whereas if you have some generalized amorphous function that somehow does things to other things that eventually results in things being done to ASCII characters, it's very hard to understand that that's no longer needed, right? So think about that. In general, adding new systems to your code is bad, right? It should only ever be a last resort. So if you think about your program as some set of nodes that are connected to other nodes, right? So each little node circle is like a module in your program or like a function or anything, right? It's not a line of code. It's something more substantial than that. And then the connections between the nodes are like, hey, this function calls this function, or this system talks to this system, or whatever, right? Because there's generally more than one connection between one thing and another, then the complexity of the program is super linear in how many of those nodes there are, right? I don't know what the exponent is. It probably depends on your program. It's probably less than squared, but it's probably not that much less than n squared, right? So every time you add a new system, you're adding a super linear amount of complexity to your code. And this is a well-known phenomenon. If you read things, old classics like the Mythical Man Month and stuff like that, they talk about how programs get harder to maintain as they get bigger. As a result, deleting code is always, always, always better than adding code if you can do it without, destroying significant functionality. If you can't delete things and if you have to add something, make it as small as possible. Make it talk to as few people as possible, right? Now, we all kind of know this, but the reason I'm bringing it up, I'll get to in a few minutes. Here's a crazy one that completely goes against everything that I thought in school. I now prefer straight line code over things like function calls. So here on the left is some block of code, and for this example, it's only a few lines long, but imagine it's 100 lines long or 1,000 lines long, right? 1,000 line long function, that's terrible. We have to clean that up, right? So how would you clean it up? Well, you might refactor it where instead of doing all these computations and then printing the result, maybe we have a function that does some computations and then we print and we factor it out. And in this case, so this looks worse because it's a lot longer, but if the function is really long, then the amount of added size here is going to be negligible. So don't worry about that. But most people would say, like, hey, okay, this is, I kind of had to give it a generic name to fit it on the slide, but this function can have a name that helps tell you its purpose, so it's more self-documenting. You've encapsulated this functionality somewhere. You've made it more reusable. You've made this function clearer because, hey, this thing down here is about computing something and then printing it, right? That's really simple. And all those things are true. All those things happen when you do this. But what also happens is now you've added another node to your little graph of system complexity, right? Now I've got another function. I remember when I do this that this is not going to be called anywhere from in here, right? For the beginning of this discussion, suppose we're using something like C or C++ and we don't have locally scoped functions, right? So, it can only, I knew when I did this that it can only be called from here, but the longer this fades into memory, the more I forget that, and somebody new coming to the program isn't really going to remember that, right? Not only is there a question about where it gets called from, but there's a question about under what conditions does this thing get called, right? What is the global state like? And any significantly sized program probably has global state. What is the global state like before entering it? What's it like exiting it? And you can start, if you're a Fortran programmer, maybe you have a 500-line comment at the beginning of that documenting all these things, and suddenly this has become a lot more work for something you didn't really need to do. And then you change the code, but the comments don't get updated, and now your comments are out of sync with your code, and that's a big mess, right? There's not just the question about where can this be called from, but there's also the question, it's a really basic idea about a piece of code, whether it really is intended to be generally usable or whether it really is a one-off thing. And obfuscating that is not a good idea, I find. So I prefer this, right? So if I'm in C or C++, I do something where I've got some braces, I can open a new scope and do some stuff. And if there's some variable in here that's supposed to be local, because it's scoped, it won't bleed into here with another variable of the same name or whatever. And then I just put a one-line comment that would have been the same as the function name, and that's it. So I actually, if there's some code that's like 1,000 lines long and only does one linear sequence of events, I actually prefer it to be 1,000 lines long doing one linear sequence of events. I don't want to hide that fact, right? So then to get to the locally scoped functions issue, you could, in some languages, put this function definition down in here, right? And that mitigates that first problem I talked about a little bit, but it doesn't really solve it because, again, assuming this is a really big function, you're going to have a lot of functions scoped locally inside it, and the confusion comes back. Okay, so I've said a lot of things are bad. So let's say what's good, like what is a good programmer in this context of making independent games where you're trying to be really productive. I have a company, I look to hire people once and again. If I were going to hire somebody, what do I look for? Well, the answer is not that surprising, actually, right? A good programmer gets things done quickly. The things he does are robust. Because of all the reasons I've been talking about, the things are simple. He finishes what he does for real, right? I'm not going to go into this rant unless we want to talk about it later, but there's a big difference between kind of finishing something according to the letter of doing the task and like actually finishing it so that it actually works and actually can live in a code base for a while. And, he has a broad knowledge of advanced ideas and techniques, right? So this is all the stuff that you learn here in school, right? So I'm not saying that you shouldn't know about data structures or you shouldn't be awesome at programming or anything like that. You absolutely should, right? But you don't want to be too eager to take all that knowledge you learn in school and apply it everywhere, because in most of the places it's going to make a mess, right? You only want to use an advanced algorithm or an advanced data structure when it is genuinely useful and is a net benefit to the project as a whole, right? And so that's hard, right? That is this sort of operational wisdom I was talking about earlier, because it's harder than being smart, right? It requires experience to some degree. So I don't exactly know how to tell you when to use these things and when not, except to say that in your professional development, it's something that you just keep an eye on and you just keep trying to improve it. Oh, I did that thing and it ended up being a mistake. I'm going to remember that, rather than not admitting to yourself that it was a mistake or whatever, which is human nature. So you kind of have to fight human nature a little bit. A general observation that I have after all this, computer science is full of ideas that are like solutions to some problem. And when the idea is proposed as the solution to the problem, it's easy to see and it's often easy to measure how that thing helps solve the problem. And so we think that it's good, right? And this applies to like software engineering methodologies or specific algorithms or anything, right? So, if you say, we're seeing our code is too hard to understand, so we're going to adopt software methodology Z, where you comment things in a certain way, then yeah, your code becomes easier to understand and you can maybe measure that. But with all these things, there are always subtle negatives chained to the idea. And sometimes there are a whole lot of them. Sometimes there's a long tail of subtle costs. And they're a lot harder to see because they're often not about the same kind of things that we wanted to fix. They're often different things. Like, we have all these people writing comments. the code's easier to understand, but they spend all this time writing comments. Maybe they don't feel as good about their job now because they spend all this time documenting instead of doing stuff, right? And then that has a long-term impact, whatever, right? The world is very big and very complicated. And with anything, right, any algorithm, any methodology, there are guaranteed to be a lot of subtle negatives that are very difficult to see and that take a lot of time and a lot of experience to ferret out. And you need to be perceptive of that. You need to be careful about it. And then the last thing I want to say, because I was thinking, well, what if I was in school back then and I thought somebody came and gave this lecture? What would I have thought back then? And I think I would have thought, actually agreed with a lot of what I'm saying here, and I would have felt like I knew. But I would have felt like, yeah, I totally knew that. I mean, it's obviously it's better to delete code than to add code if you get the same functionality and blah, 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 right? I would have thought that I knew, but in reality, I didn't. In reality, I made these kind of mistakes over and over and over again for years, right? So despite thinking that I was smart, I immediately went out into the world and did things counter to what I thought I knew, right? And I didn't really know all these things, but the general idea that there are that you want to have perspective on the project as a whole, and that you want to try to get it done in as efficient a way as possible, that's like obvious when you say it that way, right? But actually, if you try to really deeply, intuitively understand what that really means and integrate it into your practice from day to day as somebody who makes software, it really is difficult, right? You probably don't know. I still don't understand all these things that I've said to as deep of a level as I can. So I also want to put that out there, that is kind of a lifelong challenge, to really, it's really interesting, actually. We have, so back when I was an undergraduate, the internet existed, but it really wasn't the thing that we have now, right? Like, you could kind of talk to people at other universities, but it was mostly goofing off if you were an undergraduate. There wasn't that much of substance available online yet. And now, of course, the internet's huge and it's in everybody's life. And it's full of all these people saying things and trying to share information with each other. And I think what happens very often is that you read something somebody said on the internet and you're just like, yeah, I get what that guy's saying, but he's wrong. Or like, yeah, I get what that guy's saying, but, he's right, but like I knew that. That's stupid, right? I know better than that now. Please entertain the idea as you go out into the world that usually neither of those things is true. Usually you don't actually understand what the other person is saying. They may be using words where you think you understand each individual word, but the way that they interpret their phrase is different from the way that you interpret their phrase, right? And this leads very quickly to problems. So, and it can prevent you from coming to a better understanding of computer science, right? In the same way, when I was arguing with the Doom guys on their mailing list, in the same way that I thought I understood something and I thought I knew the truth, and in reality, I didn't, but we never got to that point of them, if they could have explained that to me, like why they did what they did in a very, if it wasn't a flame war, I might have learned something years earlier than I actually did, right? So that's important. And I guess I will take questions.
Are you going to preview the witness?
Am I going to preview the witness today?
Right now?
No. Well, I don't know. Let me see.
You really said you were down there.
Well, it's kind of an entertaining idea. I don't know if it'll run at this. We're at like 1024. Let me see if I can. Oh, we're at 1280, so it'll actually run at full size. It won't run very fast on this laptop. Takes about 10 or 15 seconds to start up. Yeah, I don't know if I can move the window onto a second display. And I don't know if the hardware acceleration is going to, let's see. Because sometimes hardware acceleration only applies to one. Yeah, okay. So usually this is a really cool looking tunnel, except we deleted all our light maps. So it's like, yeah. So I'm going to zoom the camera out and sort of. So this is a free roaming environment where you kind of walk around and solve puzzles, and the puzzles are pretty cool, I think. The game is at least a year from being done, but I really like it so far. I think it's better than Braid, which I was worried about for a while. Well, people don't necessarily have to agree with me, right? Because my opinion of what's good clearly is very different from a lot of other people's. But so what you're seeing here, right? This is an open world, right? You move around at a walking pace, but you can kind of navigate it at will. It's got a lot of objects in it, little individual locales. All this is programmer art right now. I mean, there's a few objects made by a 3D modeler, but this is all temporary. So as we start going into the next year, I'm going to have an architect come in and design buildings, and then we're going to model them for real, and it's all going to be very expensive. But what you see here is more about moving things around and like designing the world, right? So I can pop open the editor, take a few seconds, and oh, the editor is kind of, I guess we're not really at 1280. Anyway, I guess I want this side. So I can like grab stuff and group it and move this area across the world or whatever, right? And which with many 3D engines you can't do because they're about optimizing the things based on the topology of a space, right? So it's built for sort of me as a level designer to be able to play with things. So like here's a whole group, and I can like blah blah blah. Just like you would expect from any 3D editor, right? But the difference here is that everything down there has gameplay semantics. Like if I save and reload this, I can go play that like 2 seconds later, right? It's not just 3D models. It's let me see. So if I come back to this display, so here's like collision volumes being visualized, and like sorry, I keep losing track of my cursor. Here's like terrain. Yeah, so one of the few pieces of technology that I've done in a long time that I didn't actually regret was this sort of terrain manipulation system. So in past projects that I've done, for dealing with a height field like this, you tend to have a relatively standalone system because it's like a lot of, if I select a piece of terrain, I'm not in terrain, selectability. So if I select a piece of terrain, so it's a set of vertexes with a height value attached to each one, right? And because that topology is pretty simple, you can manipulate it in ways that are a lot easier than for general 3D meshes. So, but I knew from previous experience that sometimes you want to take this type of terrain and sort of, first of all, locally control it without having to import from some external tool. You want to be able to make scenes that involve messing with the terrain, but also specific objects. So like this little black monolith here, I might want to put that on top of a hill, and if the terrain editing tools are really separate, I might not be able to do that. And if I can only manipulate the terrain in batch kind of ways, I might not be able to do that. So the fun piece of tech that I did was, this geostatistics thing called Kriging, which is basically just about interpolating a surface from a point cloud. So these points here are, there's no topology assumed, well, except that it's some kind of plane topology, right? But there's no topology in the control point info, and I can start messing around and dragging these points around, right? And it'll interpolate that surface, which is not that surprising. You're like, hey, I can do that with splines or whatever, right? But then the thing is, I can go see in this terrain. There's a whole bunch of these. It's kind of hard for me to control this because. So, I might put one of those there, but then I might have this nearby scene that's like wants to have a totally different shape, but I want to associate this with some other scene that I might want to grab and move across the map totally later, right? So the fun thing about this was like, hey, this is just a point cloud and this is just a point cloud, and instead of treating these as individual surfaces, if I want to sculpt the actual terrain in this area, I just put together the points and I do a new thing with that point cloud, right? So like I can come over here and so those were not those were control surfaces that you don't see in gameplay, and here's like actual terrain, and I can like push this button and rebuild that, and then it replants all the grass that was on it and stuff. That's incremental because it takes time to do, right? So you generally kind of edit an area, and then you go to stuff around it, and you're like, okay, let's stamp the terrain, right? So, but now I can, I can move that hill irrespective of the terrain. So it's like, oh, I want this to be over there. Whoops. And you can pretty much just do that. So that's rat holing discussion on a random piece of technology. I'm not really talking about gameplay that much because
it's not finished yet.
Well, it's not finished, but also I haven't figured out how to talk about it yet. It's pretty weird. It's pretty different, and it is what it is. I don't know. Yeah. Other questions? Yellow shirt. Yeah.
Excuse me. So this week has been my own private developer nightmare of having a project that's due today. And
Why are you here?
well, I have to eat dinner.
Yeah. Okay.
So all week long I've been pushing really hard, and there's always these decisions about. You come to a moment, you think, okay, do I do something complicated or I try to do something simple? Can I do something simple here, or is there really no way to have a specific? Can you talk about specific case is better than general case?
Yeah.
Which gets a little weird when you're doing object-oriented programming, because then you end up with 45 million objects that are all done, a hammer that only hammers nails that are dime size, which is kind of not what you want or not what my intuition leads me to. So how do you thread that needle in between, thousands of hand screwdrivers all for their own type of screw versus a general?
Well, so, earlier I said general systems are often bad, right? They're not always bad, right? Sometimes a general system is a lot simpler than 10 specific systems to do 10 different things, right? So if you're confronted with that kind of case, you by all means want to do the general, more powerful thing, right? As soon as, how many classes did you just say?
Well, I think right now, originally in the design there was 25 classes.
To do like what kind of thing?
Like not really 25 different things. Like it was.
Yeah.
It was like it had to do with a bad web servicing service that someone was giving me and parsing their weird data and trying to manipulate it.
Yeah. You just have to try, and you just have to come to an understanding of the like this is the part that I can't magically tell you, right? It's like you have to get good at looking at the problem, seeing very quickly how to decompose it into, okay, this thing's simple, that thing's simple. This thing's kind of hard. If I do it this way, it's going to make this thing harder, but if I do it this way, that's going to make this simple, but it's flakier, so maybe I'm going to do the harder thing. And, there's just, as you probably know, right, you've done something like that. There's a very complicated set of trade-offs. You just, as you see more of what people have done, the way they've approached problems, and as you yourself do things in new ways, you just get faster at that, and you see more effectively what you can do, I think, right? There's no, piece of magic. But any kind of, parsing input for a web thing shouldn't be that complicated, in my opinion. Yeah. Yeah.
What's it been like doing things like the Humble Indie Bundle and Steam sales?
Yeah, okay, so the question was about Humble Indie Bundle and Steam sales and stuff, which is sort of a business question. It's fine. You make something and there are different ways in the world that you could sell it to people. Humble Indie Bundle's been great because it's cool. It gives money to charity. It people can pay what they want, right? So they can pay $2 for 5 games if they want. But ultimately, that's not that important of a question. And the reason is that if you get to the point where you're actually asking yourself, should I sell my game for cheap on Steam because more people will buy it or whatever, that is a really good problem to have because it presupposes that you finished a program, that the thing is playable and that people will want it, right? All of which are much, much more difficult than making the right decision about where to sell something, So I'd say focus on those things, right? Because not only is it insanely hard to make software, but to make that software be some kind of compelling entertainment experience is like, that's really asking a lot more, right? I really cannot impress upon you how difficult it is, and a rewarding task when you manage to do it, right? So, yeah, I don't know. I don't know what else to say than that. Yeah, those are lower priority things, I think. Tom, we'll do Tom.
Yeah. So you talked a lot about some of what you would probably term as your maturity as a programmer.
Yeah.
But obviously you've also matured as a person, well, maybe now.
I hope.
Over that time. If you went back to your earlier projects,
yeah,
were not successful, or you don't feel successful with, do you think that the maturity of your programming or the maturity of you as a person is more important, would be more important to be able to finish those things and complete them?
Yeah. It's hard to separate out like that because it's kind of tied together. Kind of not. Like, you can imagine being a really good programmer and a really immature person. Like, I'm sure we've met people like that, right? But again, there's that difference between being smart and being wise, or at least being wise relative to who you were. I'm not going to make any claims about absolute wisdom in any way, but I'm wiser about programming today than I was when I walked out of school, right? I think, unless I've been somehow walking backward the whole time, which you never can quite tell. But yeah, there's something about getting a little bit of that wisdom does make you a lot more effective, or it makes you not spend time on things that you would have obsessed about before, or and it depends on what scope you look at things at. Like, if you're going to say, does it help you make a better 50-line peephole optimized in assembly function to like do some sorting problem faster? For a really small, really focused problem like that, maybe not, right? I mean, maybe you learn after a few years of doing things like that most of what you need to do a good job at it. I don't know. I haven't done that much of that kind of thing. But when you look at really bigly scoped things, right, you start leaving the realm. I play with this idea a lot in game design, actually, right? There's different parts of your mind that behave different ways, right? There's like this symbol processing linguistic part of your mind that like can logically approach a task and do analysis and like see what steps are necessary to take, right? And that is not that big of a part of your brain, but we use it a lot in Western society, right? And it's very effective. We've learned how to use that very, very effectively. A lot of your brain does not work like that. A lot of it is very nonlinear, doesn't know that much about language, and like stuff just happens, and somehow it communicates to the rest of your brain, right? And the bigger a project gets, the less feasible pure analysis is, right? It's like a Go game. If any of you guys play Go, right? The board is really big, and there's a lot of intuition, especially in the early game. But then there's points in the game where it's all reading moves ahead and making analysis, and then it goes back to intuition, right? And a large software project, I think, is like that. And I think growing as a person helps that intuitive side, certainly, and it helps you aim and focus the analytical part. I don't know if it helps the analytical part. It's not my specialty. I'm sure a brain scientist would love to talk about this. Yeah.
I'm just wondering, how did you think of Braid? Like, what kind of acid trip were you on when you just like came up with the different puzzles?
I was on the acid trip of observing the natural consequences of what-if questions. So it's almost like doing math, right? So math is about, you take some axioms, you assume that they're true, and then you say, well, what follows from that? And can we find the most interesting or most beautiful things that follow from those axioms, right? So with Braid, early on, I knew that the idea was to ask what-if questions. Like, you go from world to world in this game, and time behaves a little differently in each world, and I knew that. And so in one of them, you can like rewind, and in one of them, you rewind, but some things magically don't rewind, and in one of them, like, time is mapped to your position and stuff, right? So those are the questions. And then the puzzles were just a process of taking those as axioms, which you could go back and fudge a little bit if you saw that changing their direction a little bit would make more beautiful answers. But it really was about taking those and then seeing what the consequences were, of which there are possibly many, and then curating the most interesting ones and putting those together into a package of 12 things and saying, hey, player, these are the most interesting things I found by exploring these axioms, and here they are for you to play, right? And the other ones I cut. The other ones I didn't put in the game. So yeah, right there.
Have you ever thought about making some DLC for Braid, like a bunch of levels that you never actually implemented, just like a pack of like different things for players to explore?
Yeah, people asked about that, if there would be a downloadable expansion of some kind. For a little bit, I toyed with the idea of, friends of mine or other people who had worked on the game could just like make some levels and put them in. It's not necessary, though, I don't think. The game itself is an intact work. It sort of stands by itself, and I didn't see the need to put anything else there. Now, that said, I did release on the PC a level editor. It's a little bit hard to use. It's actually the earlier version of this same editor. But because Braid is packaged for release, there's a few more steps involved in using it. And some people on the internet used it and built some levels. And if you actually search enough for it, you can find those. But they're not necessarily professionally curated in the same way as like something that we would release, right? But they're kind of, you can see a lot of interesting ideas in those. Let's go way in the back. No,
You
yeah.
mentioned that there were, maybe 6,000 lines of code in the entire project that needed optimization.
That number is totally pulled out of nowhere, so keep that in mind. But yeah, it's something like that.
I was just curious, what parts of the game typically lend themselves to be bottlenecks that need optimization?
It really depends on the game and the platform. So Braid on the PC didn't really need optimization, maybe a little bit of loading optimization. Braid on the Xbox 360 needed a lot more because it's a slower computer than most modern PCs are, right? And so actually the particle systems in Braid had to use assembly language-ish intrinsics to like use SIMD instructions and stuff. They're harder to implement than particle systems usually are because when you go in Braid and you rewind the scene, the reason you can rewind is because a compressed version of that scene is stored in a buffer somewhere, right, for every frame that you played in that level. And that can be a memory-intensive thing, so some effort goes into compressing that, which means and the art style of Braid has all these particles on the screen, and if you were to store the position of every particle every frame, that's a lot of memory, right? So the particles are all deterministic. There's like some particle source that has a seed on it. You throw that seed into a random number generator, but you don't know what time you're going to look at it. So every particle has some index based on what time it is, and you take that index, you combine it with the seed, you throw it in a random number generator, you pick a few numbers, you throw that in a bag, you shake it around, and then you generate all the parameters for this particle, of which there's maybe 20 or 30. That turns out to be kind of slow, a lot slower than particles usually are, because you have to do a lot more. And then there's just a lot of memory bottlenecks in that process. And like I said, on the 360, if you go to memory and come back, that's very expensive. So that required some optimization. Rendering state changes. Anytime you're dealing with 3D hardware, if you want to change your texture map or your shader, right, which are the things that control how a surface looks, that is an expensive operation. So you end up sorting objects by in order to minimize the amount of rendering state changes that you need to issue. That one is pretty much universal. If you play a game that uses 3D hardware, it probably does that, or else it's a very simple game. And I don't know, it depends, really. Some optimization is almost always necessary, or at least knowing what would be egregiously slow so that you don't do that, and so you don't exactly do the optimized thing, but you do something that's good enough for now, right? I'm a big fan of good enough for now, because that's really, because usually, often good enough for now ends up being good enough for shipping the thing, so, yeah.
Say you learned a lot from Doom when they released the source to that. Do you ever plan on releasing the source to Braid? Is it possible?
Do I plan on releasing the source to Braid? Is it possible? I would like to sometime. However, the thing about Braid is the environment today is different than it was when I was in school. When I was in school, you couldn't really get the source code to a game unless it was like, something like NetHack or something like that, which is a very specific type of game, like ASCII stuff on a grid. And so if somebody were to release a source, it would be very valuable as a learning experience or whatever. Now that stuff is all over the internet for lots of different games and demos that are easier to approach than a game, because it's like here's a case study in how you do a reflective surface that reflects the environment around it dynamically, right? I feel like that stuff is a lot more valuable than releasing the Braid source code. And so I just haven't done it. There's, anytime you're going to release code like that, there's potential legal liabilities. You have to go through it. It's 90,000 lines. I'm pretty sure what's in there, but I don't exactly know, and I have to go, and it's just like I've got other things to do. I don't know that it would be that valuable because really what made Braid get finished is hard work. It's not starting with any particular magic source code that does the job for you, right? That said, if somebody wanted to make something very much like Braid, it might help. I don't know. But yeah, someday in the future I might do it, but I've had too much going on. Yeah.
How does C++ fit into your thoughts?
How does C++? Okay, so I intentionally stayed away from saying very specific things about C++. Most of the stuff that I said, I think you would not find that much argument from other professional video game programmers with a lot of experience. They would all say, yeah, don't over-engineer, don't over-optimize and stuff. There is a fair bit of difference, though, in opinion when it comes down to, programming style, line to line, what does your source code look like, right? I'm in the school of thought that does not use most C++ features. I use templates in like a couple of things. Like the array class that I use everywhere is templated by the argument, type. I use single inheritance, and I don't think I have anything more than 2 or 3 deep inheritance, and that is there's a very basic structure of like, I've got this thing that's called a portable, which means you can serialize it, save it, and load it, and then I've got an entity, which is an object in the world. It turns out that distinction isn't even necessary, but I didn't know that when I made this class hierarchy, because I never want portables that aren't entities. But an entity is something that has a position orientation in 3D space and some other properties. And then there's usually one other subclass, which is like the specific type of object. Like this is a button or this is a door, right? And that's it. That's as complicated as it gets for stuff that I write. One of the guys who works for me does things that are a little more C++-ish. I have a lot of friends who follow that kind of philosophy, where C++ is basically like, C with you can declare a variable anywhere and you can put functions on structs and whatever. Some other people who work on large teams will say, no, you really do need to use a lot of C++ in order to enforce certain coding standards so that the program doesn't become a mess, right? As all these people are trying to work on it. I don't like working on teams that big. Like some of these teams have 20, 30, 50, 100 programmers, right? I don't want to be on a 100 programmer team. So in the realm in which I work, I use simple C++. However, regardless of whether people use the simple version or the more complicated version that uses a lot of language semantics, almost everybody thinks C++ is a really ugly, lousy language, and we use it because it's what we can use to get things. There isn't an alternative for a lot of reasons, some of which are historical, like we have to link against libraries that are compiled from C++ and like whatever. A lot of which is not historical, like a lot of new languages are garbage collected and people don't feel that works well enough. Like if you're at a game running 60 frames per second, you need to hit that deadline you'll fail certification if one of your frames is too long, you can slip a little bit, but I think it's like if they can find a second in which you miss 60 hertz by, 50% twice, you fail cert or something like that, right? So if a GC kicks in, you're like, oh, I just failed, right? So they're very, which doesn't mean it's impossible, right? It just, a lot of programming language research is in directions that don't make people who are doing this kind of real-time-ish program, it doesn't make it look appealing, right? But yeah, nobody really likes C++. And C++ OX is like, oh my God. It's like, yeah, they've added some things that we really like, but like, they've added, right? They didn't subtract. So, yeah.
Something nice about game programming where computers act like computers, there's random CPU. And
today people don't think about that stuff.
Well, today you do A equals X, A equals 5, and there's probably a MySQL access that's going to happen.
Yeah. Yeah.
So what are the lessons to carry over from game programming to these newfangled ways of doing
Well, I don't exactly know. So one other thing that I would like to say is that I'm not attempting to prescribe an aesthetic to all programming everywhere, right? What I'm saying is very specifically about relatively, medium to large programs that have to be performant, that are done by a small number of people in a small amount of time, where small amount of time is still like 3 years. That's kind of a long time. People who do a lot of database stuff or like enterprise automation, whatever it is, they have different concerns, right? And I would expect, though, that the pressure is always toward being higher level in terms of what you can express, right? Until performance messes you up, and then you just have to kind of sit down and get more to the metal, right? But it doesn't surprise me that like A equals 5 causes a rocket to fly to the moon and like set up a laser to bounce back something, right? But it is a mess, I don't know. I mean, I feel like sometimes people definitely don't take that stuff seriously. Like when you close, this happens less often now, and it's simply because computers are so insanely fast. But like when you close an application and it like sits there for 10 seconds closing, like somebody did something wrong. And you know what they did. They're following all these programming practices where they're like, every object has to have a destructor, and I have to do blah, blah, blah. And it's like, well, no, the operating system is going to unmap all that memory as soon as you close. You didn't, but they've adopted some paradigm that makes them, because they believe the paradigm, they've chosen to ignore the fact that they're spending a lot of effort to do something that is free, right? So I don't like it, but it's kind of the natural evolution of things, and we have to see where it goes.
What's the meta optimization problem in gaming versus in whatever this thing that you...
The what problem?
The meta, okay,
the meta optimization.
Anymore, but you meta optimize something else, right?
Yeah, well, I'm optimizing the game development process. For me, specifically, I'm optimizing the game development process to produce the highest quality game in a reasonable amount of time, right? And that highest quality game certainly has a lot of code in it, but it's got all art stuff and whatever, right? And there's probably a little bit of business concern in there, like I have to not run out of money, right, doing this. So that's a pretty high level concern, and by the time you get down to the code, there's just a lot of things in between. Did you had your hand up a while ago?
Oh yeah, I just wanted to ask. A lot of the ideas that you expressed are almost in complete contrast to what we learn in school.
That was why I chose these things to say, right? I could have easily said, hey, by using a binary tree, you can like search a thing faster.
But it's funny because we're taught, those opposites so rigorously. We're taught to, use the right data structure or to optimize the code or to use function calls to clean up your code. So why do you think that, well, actually before that, you mentioned, your Doom story, and, had I been in that spot, I would have done the same thing. I would have been like, hey, why not use a data structure?
Yeah, it's everybody learns this in school. These guys must have never gone to school, right? In fact, I don't think they did. Right. I think they graduated high school, but whatever.
So why do you think that programming is taught this way, and do you agree with it, or what is your opinion on it?
I don't have that much insight into the pedagogical process, right? Some of the people in this room do, so you can ask them. Part of it, though, I suspect, if I were to sit down and try to teach people, it's hard enough to get them to learn what you want them to learn. Like, it's hard enough to get people to understand data structures and stuff, right? You get this class with 100 people in it, and 30 of them, after 3 weeks, still get a syntax error, every single thing they type in, right? So, I don't know if it's like that still, but it probably is, right? Part of what I'm saying is it really is an advanced idea that, and it's not contradictory. It's like you do need to know all this stuff that you learn in school, but then you need to also know context of when it's appropriate and when it's not appropriate. And that's actually later, because if you didn't learn the thing, how are you going to judge when it's appropriate and when it's not appropriate? So really, I think this is additional. And if it doesn't appear in the curriculum, part of it is because they're not very focused in academia on producing things, right? And part of it is just that there's only so much you can teach, and since, so at some point things got confused, right? For a while there was a distinction between trade schools and schools of higher learning, right? And in a school of higher learning, you're not necessarily concerned with producing a thing, right? You're not learning a trade to go out and apply your trade. You're learning to be an advanced thinker and push forward the wave of thought. Like, what is computer science in the abstract, right? What do we understand as computer scientists? The point of a school of higher learning was to push that forward or do good work in there or something, right? And with computers and other fields, and I've seen this happening actually, it's gotten more and more this way since when I was in school. Things are less about higher learning and more about making things. And it's not totally true. The higher learning is all still there, but because there's so much money and there's all this like Silicon Valley and like pressure coming in, why don't your students understand this? Why don't they understand that? There's this tension that kind of pulls it in that direction, right? Which is just to say that, the CS department at UC Berkeley, who's to say it's supposed to be a trade school, right? I mean, if it's a school of higher learning, maybe you're not supposed to learn the things that I just talked about. These are very much trade things, right? They're very much about, I want to finish this large project. I don't know, Doug's shaking his head, so.
I would think the opposite.
He has more experience in academia than me.
The specific data structures and stuff, those are what you should learn in trade school.
Oh, you think so?
And I think the higher sort of how you should think about programming.
Oh, I see. So it's like I'm the code monkey, so I know what data structure to put in when my that's true. But it's complicated. I mean, the very fact that we're having this discussion means it's not obvious, right? I mean, not that we think about this professionally. Yeah.
This is a slightly less serious question, I guess.
Yeah.
When you were making Braid and designing the levels, did you just have some, childhood obsession with Mario, or did you end up the same way for?
No, I never had a Nintendo, so I didn't really play Mario games. The reason Braid was kind of modeled after a Super Mario kind of game was because it's sort of a prototypical or like a canonical, simple kind of universe. Like I've got this little guy and he can jump, and the way he jumps is not complicated. It's not like some physics ragdoll simulation. It's like bounce. And the other guys have very kind of binary states, like this guy's alive and he's walking at a constant speed, and then I bounce off him and he falls off, right? These are very simple relationships between things in the world, and there's a small number of them, and that means that the player can learn that very quickly, right? So that then, and I knew that was necessary, because then when I come along and like start playing with time and doing wacky things, if the world was already really complicated, it wouldn't be that clear what was complicated because time was making it complicated, and what was complicated just because it already was, right? So I wanted a simple world that could then get convoluted, and the way I did that was just, platformer just popped straight into my head, and I just went with it.
So the whole flag dropping, dinosaur walking out of the castle, princesses in another.
Oh, all that is definitely inspired by Mario, but it's because I chose that.
Right.
It's like acknowledgement to the earlier work in the genre, right? Yeah. We've been here a long time, so anyone feel free to leave or something. I don't know how these work. You had first.
You said you worked on many projects before Braid which didn't quite get completed, right?
Yeah.
What was special about Braid which made you complete it? I mean,
What was special was it had been a long time since I finished anything on my own, and I sat down and decided that, damn it, I'm going to finish something this time. I am going to, in order to that end, right, so that I can finish this, I'm going to make something that is technically pretty simple, right? So before this, I did a lot of things that were 3D. I did a lot of things that were motivated by hard technical problems. Like, yeah, I'm going to solve this computer vision problem and make an awesome game with it or something, right? And it turns out to be mostly unsolvable. And I kind of could get something, but it's kind of scraggly and not something you can base a game on, right? And that happens over and over where I'm sure a lot of people can empathize. I was really driven by that excitement of yeah, I think I'm smart. I think I'm a good programmer, so I can totally do things that maybe a lot of people wouldn't think that they could do, so I'm going to pick something really hard and I'm going to go do it, right? And at some point I was like, you know what? These things are really hard. And And why don't I just pick a medium hard thing? Because in my experience, it'll end up being a lot harder than I thought, and we'll see how it goes. And that's what happened, right? So another reason I picked a platformer is because I could do it in 2D, and that gets rid of a lot of complicated 3D graphics and engine stuff. Despite that, I still had to optimize the graphics. I still had to put a lot of thought into the rewind system. There were interesting technical challenges there anyway, but they weren't the kind of thing that I used to attack. They weren't like Don Quixote technical problems. And that was sort of the difference.
So, can I leave an answer? So, you did not, you ended up finishing Braid because you developed as a program and you realized you wanted to attack certain things and not others. As in, you wanted to tackle certain problems, you don't want to make your own game complicated.
Yeah, and I also, to add to that, I also wanted to focus on design this time, right? I didn't want programming to eat all my time because I wanted to design an interesting game.
Okay.
Yeah.
So, you're saying that you're never going to start another project which you're not going to complete?
That's not true, actually, at all. Since Braid, I did 2 or 3 prototypes, some of which probably won't be completed, right? But there's a difference between starting something knowing that it's exploratory and you're not going to spend that long on it, and starting something thinking you're going to finish it in 2 years and then spending 4 years and then getting depressed and giving up, right? So it's controlled